Hello and welcome to video number 14 in this series. In this video I'll apply what we know about adding and subtracting fractions to adding and subtracting rational expressions. So way back in video number 5 we reviewed adding and subtracting fractions. So for example 3/5 plus 1/3, and we need to find common denominators for this. So an easy way to do that is to multiply each fraction by another fraction that's equivalent to 1. And for the first fraction, we need to use the denominator of the other fraction, so 3/3. And for the second fraction, we need to use the denominator for the first fraction, so 5/5. And that way, we end up with a common denominator of 15. So we end up with 9 plus 5/15, which is equal to 14/15. So we apply essentially the same idea when we're adding or subtracting rational expressions. So as an example, if we have 2x plus 1 and we want to add x over x minus 2, we just write it down again and leave a little bit of space, like this. And we need to have two fractions here that are equivalent to 1 that will allow us to work with common denominators. So just for the first fraction, or the first rational expression rather, we look at the denominator of the other rational expression, so x minus 2. And for the second rational expression, we look at the denominator for the first rational expression. And then now we've got common denominators. So in the numerator, we'll have 2 times x minus 2, so 2x minus 4. And then for the next part, we've got x plus 1 times x, so we've got an x squared and an x. And then in the denominator, we'll have x plus 1 times x minus 2. And then we can simplify the numerator here. We'll have an x squared, and let's see, 3x minus 4. And that's a quadratic. And anytime we see a quadratic, we're always trying to factor it if we can. So in this case, we need two numbers that multiply together to give us minus 4, and that add to give us 3. So I think, let's see, a 4 and a minus 1 would work there. So x plus 4 and x minus 1. That's a 4. And in the denominator, x plus 1 times x minus 2. And as always with rational expressions, we need to note any values of x that aren't permitted in the domain. So in this case, that would be x not equal to minus 1 and 2. Subtraction works very similarly. We still need to find common denominators. So let's do an example of subtracting rational expressions. Let's do x over 4x minus 1 minus 1 over x plus 2. So we'll have x over 4x minus 1 times x plus 2 over x plus 2. And then we'll subtract 4x minus 1 over 4x minus 1 times 1 over x plus 2. So in the numerator, we're going to have x squared and 2x minus 4x and then plus 1. In the denominator, 4x minus 1 times x plus 2. So in the numerator, we got x squared plus 2x minus 4x and minus 2x, and then plus 1. and that factors into x minus 1 squared, and in the denominator 4x minus 1, x plus 2. And that's valid for all x not equal to minus 2 or 1/4. So as always when we're working with rational expressions, it's always nice if we can simplify the final answer or use factoring along the way to simplify the calculations. So let's see an example of how factoring might simplify things. So let's do 4 over x squared minus 2x plus 1 and add 3 over x minus 1. So if we proceeded with this, we'll just kind of going through the motions and not thinking along the way, we would end up doing the following. So write down the first expression, multiply by x minus 1 over x minus 1, and then write down the second expression and multiply by, I haven't left myself enough room, but x squared minus 2x plus 1 over x squared minus 2x plus 1. And then we're going to have to do all those calculations, and we'll end up with, in the numerator, 4x minus 4 plus 3x squared minus 6x plus 3, all divided by, it's a lot. It's complicated and it's messy, and it turns out that it's too complicated in this case, because what we should have done is we shouldn't have just proceeded through the steps without thinking. We should have thought first, this quadratic in this first rational expression in the denominator, that factors. And in particular, it factors into x minus 1 squared. And so just by doing that first step, we've made the entire problem much easier to solve. Because now we can see that the common denominator here is x minus 1 squared. So this already has the common denominator in its denominator, so there's nothing we need to do to that first expression. All we need to do is re-express this rational expression with the common denominator. So that just means multiplying it by x minus 1 over x minus 1. And then now, in the denominator, we've got x minus 1 squared. And in the numerator, we'll have 4 and 3x minus 3. And so we can go one more step and say this is equal to 4 minus 3 is 1. So we'll have 3x plus 1 in the numerator and x minus 1 squared in the denominator, and that's valid for all x not equal to 1. As another example, let's do x plus 1 over 2x, and this time let's subtract the rational expression 4 over x squared plus 3x. And again, we want to be thinking as we're moving through the steps and looking for opportunities to factor. And we can see right away that the denominator in that second rational expression can be factored. So let's start there. So x plus 1 over 2x minus 4 over And a common factor here is going to be x, and we'll be left with x plus 3. So now the common denominator for these two will be 2x, x plus 3. So x plus 1 over 2x times x plus 3 over x plus 3. And we're subtracting 4 over x, x plus 3 times, so the common factor is going to be 2x, x plus 3, so I have to multiply by 2 over 2. So we'll have in the numerator x squared and x and 3x and 4x and 3 minus 8, and then in the denominator we've got 2x, x plus 3. Let's see if that quadratic in the numerator will factor. We're going to have x squared plus 4x minus 5. So we need two numbers that multiply to give us minus 5 and add to give us plus 4. So I think plus 5 minus 1 would work. And then in the denominator, 2x, x plus 3. And this is valid for all x not equal to minus 3 and 0. So pause the video at this point and see if you can work through the next two problems and use factoring where you can and try and do the addition or subtraction and simplify your final answer, and also make a note of any values in the domain that are permitted. So the first problem that I want you to work on is 1 over x plus 2 plus x over x squared plus 3x plus 2. And then the second one I want you to work on is x minus 1 over x squared plus x. And we'll do a subtraction this time. We'll do x minus 1 over 2x squared. So hopefully you found the following two results. So for the first one, first thing we're going to notice is that that quadratic in the second rational expression, we can factor that because we just have to find two numbers that multiply together to give us 2 and add together to give us plus 3. So the two numbers that work there would be plus 2 and plus 1. And then we've got a common denominator of x plus 2 times x plus 1. So there's nothing we need to do to the second rational expression. We just need to get the first rational expression to have that common denominator. So we'll multiply by x plus 1 over x plus 1. So we'll have 1 over x plus 2 times x plus 1 over x plus 1, and then x over x plus 2, x plus 1. And then finally, we just need to figure out what's in the numerator. So we're going to have x plus 1 plus x. So that's going to be 2x plus 1. And then in the denominator, we've got our x plus 2, x plus 1. And that's good for all x not equal to minus 2 or minus 1. And then for the second one, we can factor the denominator of the first expression, pull out an x, and so our common denominator is going to be x, 2x squared, x plus 1. So the first expression, we're going to have to multiply by 2x. And then the second expression, we'll multiply that by x plus 1 over x plus 1. And then figure out what's in the numerator, and hopefully it'll simplify. We'll have 2x times x, so 2x squared, minus 2x. And then here we've got minus x squared. And we've got plus x minus x. So that's going to cancel out, and we'll just be left with minus 1 minus minus 1, so plus 1. And then in the denominator, we've got 2x squared, x plus 1. And let's see if we can factor that quadratic in the numerator. We got 2x squared minus x squared, so we got x squared minus 2x plus 1. So that's x minus 1 squared. And then we got 2x squared, x plus 1 in the denominator. And that's good for all x except for minus 1 and 0. So that's all for this video. And in the next video, we're going to bring together a lot of the ideas from the last few videos and see how that helps us simplify complicated expressions, more complicated than these ones.